Hello and welcome back. Uh, what are we doing today? Index laws? Expanding brackets? Let's have a look. We've got simplify, expanding any expressions in brackets. So for A, we've got r cubed plus s cubed, then r cubed minus s cubed. For this, we will just want to apply FOIL. So the first, the outer, the inner, then the last. So we'll have r to the 6. Remember, r cubed times r cubed, we add the powers, plus r cubed times negative s cubed. So r cubed, s cubed, s cubed times r cubed, that'll be plus r cubed, s cubed, and then minus s to the power of 6. We can see we've got some terms that'll cancel out, this, and we'll be left with something quite nice, r to the 6 minus s to the 6. That's it for A. Now for B, maybe I'll do it here. We've got m to the 5 plus n to the 5 in brackets squared. Now be careful. Be careful. I'm going to do this in red. A lot of people, I've seen this a lot of times, they'll just do this. M to the 10 plus n to the 10. There's a reason I've done that in red, because that ain't right. That ain't it. Let's see what we should do. So whenever you've got a single bracket being squared, just write both. Because what that does, it reminds you, oh, I might have to do something a little bit extra here. This, we just want to apply FOIL. Same as the very first question. So first, outer, inner, last. So that'll be m to the 10 plus m to the 5, n to the 5 plus m to the 5, n to the 5 plus n to the 10. So we can gather up some like terms. We've got this interesting character here, but we've got two of them. So we just put a 2 at the front and combine them. So we have m to the 10 plus 2, m to the 5, n to the 5 plus n to the 10. That's it for B. Let's have a quick look at C now. Ooh, C is quite a hairy customer. We've got x to the power of a plus 1 in brackets to the power of b multiplied by x to the power of a plus b all over x to the power of a open bracket b plus 1 close bracket times x to the 2b. Wow. Okay, well, first of all, we've got a few brackets here. Let's expand them. So when we have a power of a power, that just means you multiply through. So we'll have x to the a b plus b times, oh, not a, my goodness, no. It'll be x to the a plus b all over, and here we've got a outside. We can just expand that. We'll get ab plus a times x to the 2b. Now what we can do is, because our bases are multiplying and they are equal, we can just add the powers. So here we've got an AB, we've got a B, we've got an A, and we've got a B. So that'll be A plus AB plus 2B all over. And same thing down here. We've got the bases that are the same. And they're multiplying, so we can just add the powers. So that'll be x to the power of A plus AB plus 2B. Oh, I see what they've done. Very nice. So we've got the exact same thing on the top and the bottom. That'll equal 1. But another way to think about it is because we are dividing, that's the same as subtracting powers. So let's write this one more time. We can have x to the power of a plus ab plus 2b minus, in brackets, a plus ab plus 2b. And that will just equal x to the power of 0, which equals 1. Ah, that was a nice question. I'll be honest, that was a really good one. Alrighty, should we look at D now? Yeah, D doesn't look too bad. D, oh, let's hope I've got space. I've got myself in a bit of a corner here. Oh no, wait, if I scroll over I can't see. First, I should write the question down. We've got P to the power of x plus 1 over p to the power of x minus 1. That is to the power of negative 4. That's being multiplied by p to the power of 8, open bracket, x plus 1, over p to the power of 2x, and that's in brackets, to the power of 4, multiplied by p squared, all over p to the power of 12, x to the power of 0. Wow, that's a big one. Let's move over a little bit. Let's see if we've got some space. All right, let's go to there. What can I do here? I know. I'll just combine these powers. So when we're multiplying bases that are the same, we can add the powers. Here, the bases are the same, but they're dividing. So what that means is we can subtract the powers. So we've got p to the x plus 1 minus x minus 1. And that's all. Don't forget the power of negative 4. We can multiply this by, we can expand this a little bit. P to the 8x minus 8. Is that an 8? Yes. Is it a plus or is it a minus though? It's a plus. Oh, so we should make that a plus. Make sure you don't do any copying errors. Keep an eye out for that. All over p to the power of 8x. That power of 4 on the outside just means we multiply the other power, 2x. That's it. Next up we've got p squared all over, oh, we've got a 0 here. Zeros are lovely because anything to the power of 0, except for 0, equals 1. But maybe if you go further in maths, you may find 0 to the power of 0 equals something else. But for now, if you're in high school, anything to the power of 0 is 1, except for 0. Let's keep looking and keep simplifying. Here, let's simplify this. We've got p to the power of x minus x, that'd be nothing. We've got 1 minus negative 1, that's 2. 2. And that's still to the power of negative 4, multiplied by p to the 8x plus 8. And because we're dividing by p, we can subtract that power minus 8x multiplied by p squared. We're almost done. This is looking not that bad. P to the power of negative 8, just multiplying those, multiplied by p to the power of 8x minus 8x, they'll cancel. Power of 8 times p squared. Oh my goodness, really? The negative 8 and the positive 8, they'll cancel out. They'll be 0. We'll be left with p squared. That, very satisfying. Oh, I've had a great time with this question. But unfortunately, that's all the time we've got for today. So I'll see you next time.